Let's see another problem based on heap data structure. So this is a find median from data stream. Let's understand this and then we'll go through the code. This problem seems hard, but once you understand this logic, it will be very easy. And we also know the heap data structure. So let's understand, and then we'll try to understand the logic and then come back to the golang code and the Java code. So in this example, it's saying that, okay, the median is the middle value in the order integer list. If the list of the size list is even, there is no middle value, and then median is the mean of the two middle values. So in this case, this is the odd number. So it's a 3. So 1 to 3. So in that case, this 3 is median. In this case, even, there are two numbers. Then we'll take 2, 3 and add, divide by 2 is a 2.5. So that's the median. But in this problem, if you see the input here, the add num or find median. So the number keeps coming. Let's say 1 comes and we'll find the median of 1. So 1 is 1. Then we can add 2, another number 2. So there will be 2 number. Then we can add this 1, 2, 3, divide by 2 is a 1.5, find median. Then later again add another number, and then we'll try to find the median of all these number. So this is this number is saying like find median from the data stream. So that number like keep coming. So that a data stream, that's not a fix, it's a keep coming, and then we keep finding the median of the numbers. So that's the way. So let's see how to solve this problem. So let's copy these two examples here. And move to the another screen. So the way we solve is we need two data structures. So it's a two heap data structure. One is the max heap and other is the main heap. So we'll create this in a Golang, and we can use priority queue in a Java to create the max heap and main heap. So when the number comes from the stream, we always put the first number in a max heap. We'll check that max heap lane is 0, then we always put the first number here. So let's see for this example 2, 3 and 4. So in this case, when number 2 comes, we see that, okay, max heap is empty, so it goes to max heap 2. So that's the one piece of logic. Then as soon as we put the data in this data structure, we have to rebalance heap. So we'll see how to rebalance. So we added 2, and there are rebalance logic. So in a rebalance logic, we'll first check if the max heap length is like max heap size, it's a greater than mean heap dot size plus 1. So this size is greater than this size. So then we'll move the item from max heap to main heap. So that's the one logic in a rebalance. Otherwise, we'll check if main heap dot size greater than max heap dot size. So that means main heap size, this is greater. So if it is greater, then we'll move the top item from this to max heap. So that's a rebalance logic. So we see here we got the one item 2, and then we'll try to rebalance this. So we'll check the max heap size. So max heap size is 1, is greater than max heap size. It's a mean heap size plus 1. So mean heap size is 0. So 0 plus 1, and this size is also 1. So it's equal. So it's not a greater. Then we'll not do anything. Go to the B. We'll check mean heap size is greater than main heap size greater than this. No, it's not. So we'll not do anything. For the one item, we just put in a max heap. Okay, so the 2 is done. So next we'll get item 3. So once we get the 3, we'll come back and we'll check this max heap is empty. No, it's not empty. If it is already there, then we'll check this item, whatever the new item comes. The new item, there's a here 3 is less than 2 or not. If it is less than, then we'll put it here. If it is not less than, then it will goes to the main heap. So in this case 3 is not less than, then it will go to 3 goes to the main heap. So that's the logic here. Like we'll always put the first item here, and when the second item comes, we'll check, okay, second item is less than top item in a max heap. If it is less than, then we'll put it here. If it's not less than, we'll put in the main heap. So in this case 3 goes to the main heap. Now let's rebalance the heaps. We'll check, okay, max heap size greater than main heap size. Both sides are 1 here. So max heap size 1 greater than mean heap size plus 1, like 3 plus like 1 plus 1 2. No, max heap size is not greater than mean heap size 1, so we'll not do anything. We'll check here mean heap size, this is greater than this. No, so we'll not do anything. So next the item 4 comes, then again we'll check 4 is less than top item. So 4 is less than 2. No, if it is not less than, then we'll put it here in a mean heap, and we know that in mean heap the mean item will be at the top, so the 4 goes here. Okay, come to the rebalance logic. We'll see that max heap size greater than mean heap size plus 1. No, max heap is 1, it's not greater. We'll check mean heap size greater than. Yes, mean heap size greater than. Mean heap size greater than is the max heap size. So in this case we'll move this top item to the max heap. So in this case the top item in the mean heap is 3, so we'll move this 3 to here, and in the max heap 3 will be at the top. Okay, so this is done. So now the final thing is first we added all the items, we rebalance the heaps, and then we want to find the mean. So when we find the mean, so median, then we'll check. There are two logic we'll add here. Like we'll see that, okay, this max heap is first max heap and mean heap are length are same. So if the length, so max heap size or length equal to mean heap size, if both are same, so if both are same, then we'll take this top item, add it, and then divide by 2. That will be answer. But in this case, this is max heap is not equal to mean heap, and in that case what we'll do, we'll take the top item 3, and that will be the answer. That will be the median. So 3 will be median in this case. So we'll see the pattern here. At the end, when we add the item and rebalance the heaps, then in that case this max will be either 1 more than the mean heap, or the length of both max heap and mean heap are same. If it is same, then we'll take top item from this top item, add this, divide by 2. That will be answer. And if it's not the same, they will take the top item from the max heap. So that's the strategy we are going to use in the code. So let's see how to write the code for this. So in a golang, we have to define 2 data structure. So one is the mean heap and another is a max heap. So let's see, this is the init mean heap, and we have to implement this 5 functions. So len, less, and then swap, and then again push, and the pop. We have also seen this thing in the previous example where there's a hand stretch problem. So okay, so this is the main heap, and if you define the max heap, I have just copied everything and paste it here and change this to the max heap, and this name max heap, and then one condition I have check here, greater than. So if I put the less than, then that will be the min heap, and if I put the greater than, that will become the max heap. Okay, so that is done here, and I have also implemented the pop and the push. So that's the 5 functions the same. So I have created this 2 data structure definition here. Next thing is, let's see how to call this. So there are the constructor, there are add num and the find median. So constructor will use the constructor, and this function will add num and then find median. Okay, so first so this is the struct. So in a struct, I'm initializing them, I'm creating the, or let's say defining this variable max heap and the min heap. This is the init max heap, init min heap. We have whatever we have defined. This is the type, init max heap and min heap. So we create the definition for this, and then there's a median finder. This is a constructor, and in this constructor we'll initialize max heap and min heap. So initialize this max heap, min heap, and return the object. So this is the constructor, that's the median finder, that's a struct. So I'm going to return the object for this, where I'll just wrap this max heap and min heap. So I'll just put here max heap and min heap. Okay, so in this way we return this object, and that contains max heap data structure and min heap data structure. And then our actual logic comes to the add num. When we call this function, when this new num comes, we'll check the max heap equal to 0, its length is 0, or the new item whatever is coming is less than top item in a max heap. So in this case we'll add that item to the max heap, otherwise we'll add the item in the min heap. So here we use this logic, like when this max is empty, put that here, or we'll check the new item is less than the top max item, then put it in a max heap, otherwise put it in the min heap. So that's we handle the logic. Next logic is rebalance heaps. So next piece is rebalance. So we'll utilize exactly same logic over there. Let's see the code. Rebalance heaps. So we'll see that, okay, max heap length greater than max heap, the left one, the max heap greater than the min heap length plus 1, then add that item. So that what we do, that we'll add that in a max heap. So let's say max heap length greater than this, then this is greater, max is greater, then min heap length, then we'll get the item from the max heap and put that in a min heap. So get the item from the max heap and put to the min heap. Else, if this max heap length less than min heap, that means max is less than min heap. If the max is less than min heap, then this is the less. So we are going to put in this from min heap. So we'll take one item from the min and then put that in a max heap. So the rebalance is done, and the final logic is find the median. We'll check the both length, max heap length equal to min heap length, it's the same. Then take the top item from max heap, take the top item from min heap, and divide by 2. That's the answer. Otherwise, take the top item from the max heap, and that's the answer. Yeah, so that's a simple logic. So once we have the knowledge of this data structure, how to create the max heap and min heap, and then how to add the item, rebalance, then find the median. So that seems again easy. So it's not a hard norm. Okay, let's see the similar logic I have implemented using the Java. So let's see that in a Java. So in a Java, I have created a min heap and a max heap. That's a median finder. Here I'm using the priority queue. So the by default priority queue, if we create this object, that's a min heap. But if I want the max heap, then I want to add few things more here, and that's happened the max heap. Now we add the data in a max heap. we'll check max heap size is 0 or the new item less than the max heap top. So in that case we add that item to the max heap, otherwise we'll add the item to the main heap. And we rebalance the heap. How to rebalance? We'll check, okay, max heap size, it's a greater than, it's a mean heap size plus 1, then this is greater, so that means we'll take one item from the max heap and put to the main heap. Else we'll see max heap size is less than, max heap is less than min heap, then this is less, so we'll get top item from min heap and put that in a max heap. Okay, so we are done with the add num. We added the item, we rebalance the heaps, and then final thing is the median. We'll check the size, min heap size and max heap size, both are same. Then take the top item from the min heap, top item from the max heap, divide by 2. That's the answer. Otherwise, return the top item from the max heap. That's the answer. Okay, so that's all for today. Thank you.